Okay, so question 13 asks you to derive the equation for fractional oxygen binding to myoglobin. All right, so for ease of writing out this reaction and doing all the math and stuff, we're going to write the reaction of oxygen binding as actually oxygen release. So we're going to start with a myoglobin oxygen complex and have it dissociate into our free myoglobin and our oxygen. All right. So we can write an equilibrium constant for this reaction. Since this is the dissociation reaction, this will be a dissociation constant, or Kd. All right, so now we end up with the concentration of myoglobin times oxygen on top, divided by the concentration of the reactant, the myoglobin oxygen complex. All right, so we have this Kd value here. All right, the other thing we need to write is the equation for fractional binding of oxygen, or fractional of myoglobin that has oxygen bound. All right, so in this case, we're going to give that the symbol Y. Well, if I wanted to write the fraction of myoglobin with oxygen bound using concentration of these species, all right, first of all, in the numerator, I want the amount of myoglobin with oxygen bound, its concentration. All right, but I wanted to divide this now by the total amount of myoglobin. All right, the total amount of myoglobin is going to be our free myoglobin that doesn't have any oxygen bound, plus any myoglobin that does have oxygen bound. All right, so that's our total amount of myoglobin on the bottom. So on the top we have myoglobin with oxygen bound. On the bottom we have our free myoglobin that doesn't have oxygen bound, plus myoglobin with oxygen bound, which the sum of both of those is just the total amount of myoglobin. All right, so now what I want to do is I basically want to cancel out or remove these myoglobin with oxygen bound terms. All right, so the way I'm going to do this is by cross multiplying our first equation here, basically swapping the Kd and the myoglobin for oxygen. And so this whole top equation now becomes the concentration of myoglobin with oxygen bound is equal to the concentration of our free myoglobin times the concentration of oxygen divided by the Kd. All right, and so I'm now going to take this portion of the equation and plug it in wherever I see the myoglobin with oxygen. All right, so what am I doing here? Well, basically I'm trying to get the entire equation to not have myoglobin in it at all. I just want to have oxygen in it. So I'm trying to eliminate the myoglobin terms by doing this. That's kind of the logic behind what we're doing here, because what we can experimentally do is we're going to measure how much myoglobin has oxygen bound at different oxygen concentrations. So that's what we want to be able to have our equation have that form. All right, so in this case, once we do that substitution, we end up with kind of an ugly looking thing where we have fractions on top of fractions. So we have our free myoglobin times oxygen over Kd. All right, and this whole thing now is over our concentration of free myoglobin plus another fraction here where we have our concentration of free myoglobin times the oxygen concentration divided by the Kd. All right, now we want to try to basically simplify this down. Nobody, including scientists, nobody really likes having fractions within fractions. All right, so what we're going to do here is we're going to basically multiply just the right side here by a certain fraction to try to get rid of these Kd terms in the bottom. But we also, I want to point out, every term here has the myoglobin or free myoglobin in the numerator of each of these species here. So what we're going to do is we're going to multiply the right side of the equation by essentially by 1, but we're going to use expressions that are here. So we're going to have Kd on the top in both cases because we want to get rid of that dissociation constant in the bottom, in the fractions, within the fractions here. And we're also going to divide each part by the free myoglobin concentration. So we have that fraction up there over the exact same fraction. All right, so all we're doing is multiplying this by 1. But what ends up happening now? On the numerator, well, this KD cancels out with that KD. This myoglobin free cancels out with that one. All right, in the bottom here, well, this KD here cancels out with that. And both the myoglobins cancel out with this guy. All right, so what we're left with now, we have Y is equal to concentration of oxygen. The KD did not fully cancel out though. It canceled out for this term, this KD here, canceled out for that term, but not for this one. All right, so that KD is still there. So the KD gets multiplied by whatever was left there, which is 1, because when the myoglobin canceled out with the other myoglobin, we ended up with 1 there. So we have 1 times KD, which gives us KD there. And then all that's left of the lower term to the right here is just the concentration of oxygen. All right, so now we have our final expression for the fractional binding of myoglobin to oxygen. It is going to be equal to the concentration of oxygen divided by KD plus the concentration of oxygen. And that's it for question number 13.